Hello, one and all. I am Manisankar, studying ECE from Janus Institute of Technology. Today, I am going to explain some problems, which is for the purpose of case study of linear algebra and partial differential equations. Let us move into it one by one. Okay, here the first question is: let V is the set of all continuous real-valued functions. Okay, which is defined on the closed interval of 0, 1. Here the give. And then if inner product of f comma g is equal to integral of 0 to 1 f of t g of t dt, then we have to show that V is a real inner product space. This is the thing which we have to prove here. Let us give the solution for this problem. Here given f comma g, inner product of f comma g, which is equal to integral of 0 to 1 f of t g of t dt. So the first one is inner product of f plus g comma h, which we can be proved by integral of 0 to 1 f of t plus g of t into h of t dt. Here the thing is h and the x value is f plus g. So here we separate it as f of t plus g of t into multiply it by h of t. Then we have to separate it each f of t into h of t is one integral and g of t into h of t is another one integral with the integral limits of 0 to 1. So here you can see this 0 to 1 integral of 0 to 1 f of t h of t into dt plus integral of 0 to 1 g of t h of t dt. Hence the final result is inner product of f comma h plus inner product of g comma h. And then the second one is inner product of c f comma g. So here we have to multiply c with f of t and g of t. Integral of 0 to 1 c f of t g of t, we can take c outside the integral because it is a constant, and then if we integrate f of t and g of t, then we will get the inner product of f comma g multiplied with c. So here is the answer, c inner product of f comma g. And then the third one is inner product of f comma g itself. So we have to multiply it directly, or if we make it reverse, means integral of 0 to 1 g of t into f of t also gives integral of inner product of g comma f. And then the final one is inner product of f comma f. We can substitute it as the integral of 0 to 1 f of t into f of t, both are f of t, means then we will get the value as modulo f of t whole square dt, which is greater than or equal to 0. Hence f comma f, inner product of f comma f is equal to 0 if and only if f is 0. This is the final result we obtained here. And then if we move to the second problem which we have here is obtain an orthogonal basis for V3 of R with standard inner product containing the vectors 1, 1, minus 1, and then the other one is 1, 0, 1. So here if we see about the solution, we have given vectors are 1, 1, minus 1 and 1, 0, 1. If the x, we take the x as x1, x2, x3, which is a vector orthogonal to both the given values 1, 1, minus 1 and 1, 0, 1, which are less, then we have solved like inner product of x1, x2, x3 with the first value 1, 1, minus 1 is equal to 0. Then we will get x1 plus x2 minus x3 equal to 0 when we multiply x1 with 1, x2 with 1, x3 with minus 1. Okay, and then for second value x1, x2, x3, inner product of x1, x2, x3 with 1, 0, 1, we will get x plus 0, x1 plus 0 into x2 plus x3 equal to 0. So x1 plus x3 equal to 0 is the second equation we get. So then we have to solve this by subtracting it 1 minus 2. Then we will get the answer as x1 plus x2 minus x3 minus x1 minus x3 equal to 0. So here we can cancel the x1 and minus x1. So we will get x2 minus 2x3 equal to 0, and then if we substitute it x2 equal to x3, the final we get x2 by 2 equal to x3 by 1. This is the value we get. From the first equation we have to substitute the answers. So x1 plus 2 minus 1, here it is 2 minus 1 which is substituted for the values x2 and x3. Okay, and then if we substitute the values with 0, then we will get the answer as x1 value -1, x2 value 2, x3 value 1. So the result hence 1 comma 1 comma -1, 1 comma 0 comma 1, the given values, and then the -1 2 1 which we obtained is an orthogonal basis containing the given vectors. This is the result we get here. Thank you.